would like to welcome Justin Wolf. So he has got wealthy industry experience of about 25 years, and he's managing client and server technologies, and currently his team is focusing on SaaS products. So here we have Justin for the morning talk. Welcome.
Great, thank you. All right, thanks. All right, so my name is Justin Wolf, and I work for Cisco Systems. We're down in Lake Oswego, and Scott Yoon is here with me as well in the front row to back me up for technical questions. I'm the manager. And what our product is, like in the introduction, is we do a SaaS product for service providers. We'll get into more detail on what our product is, how we build product, and of course how we test it. And most of it will be on the automated QA pipeline. I'd also like to mention that right after this, John Duart is giving a talk on why not to automate. So the two are sort of a complementary pair. And I really agree with his assertion that you need to not focus on automation at the expense of quality. I think that's the gist of his talk. We'll find out in 45 minutes or an hour or so. And then also yesterday, Lisa Krauscher and Brian Ocken were talking about how to prioritize your testing and focusing on the user experience and focusing on, don't over-test your product at the expense of quality, right? So you're so focused on writing thousands of tests that you've got this big, basically QA debt that you've got to service regardless of what the customer thinks. So I think we're all kind of already on the same page with the philosophy behind what to test and how much to test. All right, so I'd like to start by saying that we're all users. Everyone in the entire world is a user. There's the two classes that we break it into are direct users and indirect users. Direct users are what everyone thinks of, right? They're the people who are interacting with the software. They're using the product, hopefully the way that it was intended, and they're using it to get a job done. The indirect consumers are everyone who then is subject to that use, right? So an example you could use is there's a spreadsheet application. The direct user is perhaps a government analyst who's using the spreadsheet application to figure out how much benefit to assign to people within a community. Now imagine there's a bug in the spreadsheet and it miscalculates how much benefit goes to those people, either too much or too little. So the direct user in this case is the analyst, the person using the spreadsheet. The indirect users or consumers of the product are the beneficiary, their family, the businesses in the local community, the management structure that's in place, the bureaucracy that's in place. Really all of society, if you use that sort of view of who are the consumers of a product, it's pretty much everyone in the world, even if they've never touched a computer. So since everyone in the world is affected by software, and nobody really likes bad software. That's one of the reasons why we need to focus so much on quality. Not so much quality assurance, although everyone calls it QA, but quality overall. So you've got, in more tangible or more proximate terms, you have salespeople, you have managers, you have investors, you have executives, you have sales channels. All of these people want to see the product moving forward, right? They don't want to see a development team bogged down fixing bugs. The development team doesn't want to do it. They want to be working on new features. The investors want new features coming out. They want the market being serviced. They want their bottom line being accelerated. And even the testers don't really want bad software, right? Testers get tired of testing the same bugs over and over and over. So how can we make that better, right? That's really the whole idea behind reinforcing the quality here. So our goal in our team, the way we look at things, is that we want to make products that people have fun using and that the team enjoys developing. So I work for a commercial company, and they expect us to make them a lot of money. They pay us. So our paycheck is a pretty direct measurement of the quality of our software. People enjoy the software, they use the software, they pay us for using the software. It's pretty straightforward feedback. But really what we're trying to do is delight our consumers. And that's a much more subtle and soft skill. And on top of all that, we're in a marketplace where there's a lot of other products that we are interacting with. There's a lot of other technologies. There's a lot of preconceived notions of what a product should do. And so sometimes it's hard for us to get the credit for when our product is doing all the good stuff that we intended it for it to do. And instead, we're getting blamed for some bad thing that some other piece of technology is doing. So in the end, though, we're not really just making software to get paid. We could do that anywhere, right? So why are we working on our product? Why are we working in our company? And it makes us feel good when we can go out to our customers and they can tell us how our software, how our product has made somebody's life better, right? So that's really what we're ultimately after. And just sort of as a sidebar on the philosophy, it's all humans to humans, right? There's no machine to machine. There's no human machine. It's all human to human. Somebody wrote the technology. Somebody sold it. Somebody bought it. Somebody's using it. That's all humans, right? It's humans doing human things. So the world went through this obsession with zero defect for a while. Hopefully it's all passed, but it's impossible, right? There's no way to make zero defect software. Even if your software is zero defect and you've done everything, you're using formal methods, you've done all your verification, and yours is flawless, it's going to get installed into an environment where millions of other lines of code are out there. And there's probably people in that infrastructure that aren't as careful as you are. So now you've got the task on top of this of every time you want to update some piece of software, every time you want to write a new line of code, every time somebody else writes a new line of code, you have all of these millions of lines of code that are all interacting, and you've got to try to make sure that none of them have any conflicts with each other, right? It's pretty much impossible. So instead, what we're really focused on is providing not a zero defect experience, but an enjoyable experience. So we're focused on the tests that only enhance or maintain a user experience. So let's take a little dive off into the weeds of non-technical quality. Our team has started using design thinking in the way that it approaches product development. And this has been around for a long time. If you haven't taken a look yet, IDEO is a really famous firm in this world. Tim Brown has written a number of books. Stanford's D School, which stands for Design School, has courses online for it. There's a lot of stuff, articles out there on Harvard Business Review and other places. But really it all centers on the prototyping step. So what we look at is when you're developing a product, you want people to use it. You want people to enjoy it. And there's nothing worse than developing a product that no one uses. Only slightly better than that are products that you develop and people use it, but they really hate using it. And so I've got Clippy here as a reminder. It's a piece of software that anyone over 30 probably has come across. And it's exactly that, right? It was trying to assist people. There's lots of postmortems have been written on Clippy. But that's an example of something that people used, but they really hated it the whole time. All right, so let's go through design thinking and how that leads to the foundation of quality, regardless of the automated QA. And we'll get to the technical stuff in a little bit. It's not going to all be high-level stuff. But you start with empathizing. And this is where you go out and you become what some people call an instant expert. You observe people in their environment. They have a problem. They have some solutions that maybe they've come up with, or maybe they don't. And now you have to figure out what is the problem that you want to solve. How are you going to solve it? How are you going to make that person's life better? So after you empathize, then the next thing you need to do is define. What is it that it's sort of your mission statement. What of all of the things that you observed, what is it you're going to solve? What is your product going to do? And that might change through the process. You might change, you might pivot, you might do other things. But you need something at the center that's sort of a kernel that everyone's working towards. But the next step you're doing from there is ideation. And ideation is a process of exploring the possibilities. There is really nothing that's too far-fetched. It could be that in order to solve world hunger, we need to send everyone to Mars, right? That's a great idea. Let's put it on the board. It'll get prioritized later. It'll get down-selected later. But you really want people to be thinking really far away from the product, as far as they can. Because you never know when somebody who just throws an idea out there has something that aligns with somebody else's far-fetched idea. The two things come together, and that's your solution, or that's a new market that you decided, hey, let's go back to step one. The idea we had, maybe it's not a great choice for our business or our careers or whatever it is we're trying to do. Let's go back to empathizing. After the empathize step, or rather the ideate step, where you have this list of ideas, that's the end of this divergent process of starting with an idea. You're going out, you're gathering all of the possible ideas that you could have for how to solve that. And now you're coming back to what is the thing we're going to prototype. And prototyping is really, I feel, at the core of design thinking and how you're using this to create a product for your consumers. So prototyping is, it's not sitting in a room with a laptop, writing a prototype, doing wireframes, making scripts, and all of this sort of rapid prototyping idea. Prototyping in design thinking is you start with a piece of paper, right? Not even a whiteboard. Sit down with some people and design the product. Make it tangible. Make it something that you can use. An example that was given to me when I was introduced to this concept is somebody wanted to create a mobile app. Well, they didn't have the technical expertise to do that. They knew they were going to have to contract that out. But they had scissors and pens, and they could visualize what it is they wanted. So they created the web app, or the mobile app rather, on this series of a really long series of paper. And then they made a little cutout viewer that looked like the phone. And they said, okay, well, you want to do this, right? So tap on the paper, and then they moved that viewer to whatever screen they had scribbled out. Okay, that's what we're going to do. So they were doing the user experience design before even getting to the first line of code. And they were able to then take that in the next step of testing back to the people they had interviewed during the empathizing stage and say, all right, well, here's our idea. How do you think this will work? Is this helpful? What would you improve about it? How would you, if you had this tool, what would you do with it? And at the end of that whole process, and you've collected those steps or those ideas, you've collected the feedback from your possible market or the people you want to help, then you make a decision. Should we move forward with this? Should we iterate? Should we go back? And now maybe we do make some wireframes in, we spec out the web app, or maybe we spec out the schema, or maybe we figure out what technologies we want to use. We talk to some experts in a particular field. We start spending money, right? It's no longer just an idea. It's how are we going to turn it into a product? So if you start with this flow, the way we do it is we actually start with the idea. The idea comes in from somewhere. It's usually, for us, it's product management, right? We work for a large company. There's a lot of resources behind us and in front of us. And product management has an idea. They're the ones who have interacted with the customer. We don't really like that. So then we go back and we validate that, right? So the product management might come to us and say, we need a button that saves documents. Like, really? Are you sure? Because that's going to be a lot of work, right? If we just let them view it and then we throw it all away, that's pretty quick. But if you need to save it, then we're going to have to re-architect something so that it can be saved. And then after that, you're going to ask us to load it, right? So we want to validate it and make sure that the feature that's been asked of us to develop actually is what customers are going to want. So we go back to the customers and we interview 3 different types of persona. We have the requester, who's usually the product manager. Might be somebody at the customer who is going to help us in developing this. There's the beneficiary. So if you've got a user, they're the direct consumer, right? They're the person clicking the button, interacting with your software. The next sort of step back from that is who benefits from that action. So if it's in our product, we work with customer service representatives or customer care, and they have managers. The managers have managers. Those are all beneficiaries, right? They hired these people to interact with the customers, solve their problems. And if those people can do their jobs better, the managers do better, the executives do better, the company does better. So those are the beneficiaries. We want to interview those people. We want to interview the users. Then we're going to do exactly what I said. We're going to do a mock-up. We're going to take it back to those people, and we're going to iterate on it if it makes sense, right? We're a commercial company. For us, it's about profit. So if it looks like developing this idea or iterating on the idea will improve our profit prospects, then we'll make that investment. We'll do it. If it doesn't, we stop, right? This is really at the core of lean, right? Don't create a bunch of stuff that no one ever uses, stuff that people don't want, stuff that people hate using, and just cut it off right at the beginning. All right, so that's enough about design thinking. All right, so the old days of working on a product, I started in the game industry. You started more or less around Thanksgiving designing the next year's game. And you developed it until late summer, early fall, and then it went to production. It went out to the shelves. People bought it, and they played it. And if they liked it, word of mouth meant more people bought it, and you had a really successful game. Well, it was a one-time event, right? We had to get it right. It was going on to something physical. It couldn't be updated. There was no internet, certainly not to consoles. So it was a completely different experience. Nowadays, it's continuous delivery. That's what everyone wants to do. Even if you're not in a as-a-service type product, then you have probably a product that gets live updates, or you have a product that eventually gets updated. It receives patches, security patches hopefully come out pretty often for you. So there's this concept of continuous delivery. And what we're trying to prevent is delivering fresh bugs to people, right? We solved that bug, but we gave you 5 more, and now you got to wait around for the next time. People definitely don't want to wait a year for that, right? Nobody wants Windows 7. So the problem that we're trying to fix then is how do we detect a bug early in the process, and how do we fix it quickly if it gets out? So we use all sorts of different techniques. There's lots of acronyms there. Behavior-driven design or testing, test-driven development, end-to-end testing, long-running tests, unit tests, build verification tests, what have you. So there's a lot of different things. All right, before we get into why we do things the way we do it, I just wanted to give you a little vignette of our product. So we produce software that runs both on a home gateway and in the cloud. And we sell this to internet service providers to allow them to configure and manage the home network. And what the genesis of the current product that we have is people like to blame their ISP for all of their networking woes. For people who are really technical, it's usually pretty easy to determine, is that a problem with the internet provider, or is it a problem with my home network, or a problem with a particular device? But 90% or more of the people out there are not like that. They can't debug their home networks. They don't even really know what a network is. They take something home, they push the button, it works. It stops working, they call their internet provider and say it's not working anymore. So our product steps in and says, okay, well, this is what their home network is configured like, this is the device they're using, this is what the problem is. And so we have this collector that takes all the information in on the back end. It does some stuff with it in the middle. And then there's a front end that the customer care agent is using in order to talk with the person at home and troubleshoot their problems. And an example of this that sort of validated our whole reason for existing is we were working with a sales engineer, and he was working with a service provider that offers 4K streaming to the home. And he said, well, I'm having this problem. I've got a large WAN pipe going out to the service provider, and other things work just fine. I can watch other videos, no problem. When I watch this video, it goes high res for a few minutes, and then it drops to low res, and it just looks like crap. So what's the problem? Use your product and tell me what the problem is. And so I went through all of the steps that a customer service agent would do. And I said, well, it looks like your Wi-Fi is great. Looks like your bandwidth is great. Your signal strength is fine. But your data rate between the gateway and the device is really low. So it's getting starved for data somewhere inside of the network. So let's go look. And we have this feature that looks at all of the channels, the signal strengths of all the channels across the 2.4 and 5 gig networks. And he was on a channel that was just absolutely clobbered. It had like 30 networks on it. And it's in a lab. It's probably a room half the size of this room, and it's got like 100 gateways in it. So I said, well, just move it to another channel where there's some free spectrum. Everything will work great. So he did that, worked great. So our product works. So that's really what the core of the product is. And we can get into more detail if you guys have questions about it. So back to the millions of lines of foundation. So here are all of the technologies that go into our product. There's a lot of stuff. There's all of the stuff that goes into building the product, into testing the product, into deploying the product. There's where it gets deployed to. There's the monitoring that goes into that. We're in Amazon. We use Elk. We use New Relic. Go Portland. So there's all that stuff. We don't really have any control over it. And when we want to update something in there, we have to make sure that this component and that component play nicely with each other. And by the way, we wrote some stuff too, right? So we've got a few things that are our product, right? That's the intellectual property that our company owns. I threw Trello in there as a developer runtime. That's how we manage our Kanban process, but that's a separate talk. So there's a lot of stuff, right? So how do you test it all? All right, so this is the transition into the technical stuff. So we spent a little time talking about design thinking and how our team gets ideas for the product, how we validate that. I'm not going to go into any more detail on that, but that's really the foundation for the quality, right? If you're building good features to start with, you're only testing good features. You're not testing a bunch of bad stuff. So that's the beginning of it. And the paper that's in the proceedings, you guys can read a lot more detail about that if you want. So a day in the life of one of our developers. They sit down, they want to write some code. They write it, they submit it to Garrett for code review, and as part of that process, we make a verification build. If the verification build doesn't pass, that code can't ever be checked in. So this is where we run all of our tests, is in the verification build. And the code review can proceed. We can have people do, if you're familiar with Garrett, you can do the +1s, the +2s. You can get it all ready to go, but until they fix the problem with the verification build, they can't submit it. It can't be merged, can't be deployed. So after that, we have this build that's tested, and I'll get into more detail about the testing on the next slide. It goes out to, everything for us is in Docker containers, so it goes to a Docker registry. The Docker registry is then controlled in its deployment to staging and production via release channels. Those are also in code control. So everything kind of flows through our pipeline out to eventually production down here. That's what we're all about. So we try to do test-driven development. Developers on my team have this sort of love-hate relationship with it. They don't really like writing tests when they're still experimenting. They don't want to write a test for something that they don't know if that's what it needs to do, or they don't know exactly how it's going to be solved. Eventually they figure it out and they've got code that solves the problem. We tend not to go back and write a bunch of tests around it. However, if a bug is found, then we write the tests and we go back and we add TDD unit tests to the bug fix. But the idea is that since the build was tested as a part of the check-in, there's no need to test it again. So we don't actually test between the real build and production. We test when it's built, and those artifacts are essentially production-grade containers. If the containers are good, it doesn't matter if you test them again or not. They're going to be good forever. All right, so let's see. We'll skip to the next test. So we do two types of testing. We do mock testing, we do end-to-end testing. For mock testing, we use a mocking server. For some of our tests, we use MSL, mocking service layer. For some of our other tests, we use ngmock E2E, which is actually baked into the JavaScript. So it's not technically a mocking server outside of the product. It's baked into the testing. But all of this is driven using Protractor. So Protractor is built on Selenium. So Selenium Hub has all of the tests. They're sent out to the Selenium nodes. They're tested off in their own containers on their own VMs. And this makes it really nice because we can parallelize all this testing. We can run all sorts of nodes, and we can run dozens or hundreds of tests in a matter of a minute or two. Just throw hardware at it, right? Great. So that's how it works with mock tests. And this is taking the product out, right? So it's just UI. We have the UI, we've got the JavaScript, the HTML, the CSS, all that stuff. All of the AJAX calls are mocked to either MSL or through ngmock. So then what do we want to do when we actually test our product behind the front end part? So our product is deployed into containers, as I mentioned. We use Docker Compose. And Docker Compose creates essentially a mocked deployment for us. And we use similar tests. They're written in Protractor. they run in nodes, but they hit a actual front end for our product, an actual REST interface. All right, so automation is kind of a double-edged sword, right? There's obvious advantages to it. You get a lot of testing with really no effort after the effort. You can test your product 10 times a day if you want, right? If there's no new tests, there's no broken tests, there's no new functionality. If you just want to run it again, you can do that. You don't have to pay people to do that. So that's on the plus side, right? And because you can run these tests, the bulk of the tests that haven't changed, the functionality in the product hasn't changed, you can get the quality from full regression testing without much incremental investment. Where the problems come in is if functionality changes, if a test is invalid, if functionality makes a test not run, but it's still a valid test, you have to fix it. And that's a continuous investment. So on our team, we have about a dozen people, and 2 of them are focused purely on automated QA. And that's like a full-time job for them. The advantage is that their efforts are multiplied because once they write the test, it can be run lots of times and in lots of different scenarios. So that helps. But if we didn't make that investment, if we didn't have somebody who was always working on the automated testing, it would quickly lose its value. You'd have tests that didn't run, you'd have errors that you ignored, whatever. Okay. So that's all I wanted to say. I think we've got a couple minutes for questions, if I'm right. Or I can go into more detail on things. We also have our paper in the proceedings. You can read in more detail. There's a few things I glossed over. I don't know for you guys what you wanted to dive into in more detail and we didn't cover, but feel free to ask questions. Yeah, in the back.
So do you test the environment separately where you're going to deploy to? Test it separate from your product? Or?
So do we test the environment separately from the product? In our case, the environment is AWS, where it's ultimately being deployed in. And so if that's what you're talking about, the Amazon environment, no, we don't test Amazon. If we find a problem in that environment, then we figure out how to fix it. We do also deploy in our own facility to an OpenStack-based VM environment that has a lot of different systems supporting scale testing and that sort of stuff. We don't have tests for that itself. But if we do find that some functionality between the laptop version of it on a developer and the lab version of it in OpenStack or in the production version on Amazon, which we also run a staging server in just to make sure that there's no differences between our lab and Amazon that cause problems, then we investigate where the problem is. But no, we don't have specific environmental tests. Yeah?
I've got a couple of questions. Let's say you're designing a product which is brand new, which has not gone to the customer side. The product is to gain customers. So in such cases, how do you get a feedback, first-time feedback? That's question number 1. And the other question is that it's not always the UI that you will have in your product. Even if you take the router or whatever Wi-Fi router products,
Yeah.
a lot of back-end job is involved. So for those things, I don't think a lot of customer interaction is there, but it's all the non-functional requirements that get into the product.
There's a lot of
How
those.
do you deal with these 2 things?
Okay. So in the first case of new functionality, how do we get the feedback from the users? So there's a couple of different ways. One of them is sitting down with them and using the product together. There's a lot of great techniques for getting that sort of direct feedback. We can also monitor it. So I mentioned we're using New Relic. We're using their browser product in order to look at the behavior of a user as they work their way through our application. We can figure out how long did it take for something to load. Did they start a workflow but then abandon it? Did they have a problem, an error at some point that we didn't expect? So we can get feedback sort of indirectly in that way as well. As far as the infrastructure and sort of non-functional, there's very few, the way I look at it, there's very few non-functional tasks. So if you have to, let's say we wanted to change from Cassandra to React for whatever reason, right? Some people might think that's non-functional, but it's entirely functional, right? Like, why are you doing that? Is Cassandra inadequate? Is there some feature in React that you're moving to? Is the customer interaction inferior with one product over the other? How is it going to change between those? So you can always pull it back up to, well, if the user doesn't know that you did this work, then why are you doing it, right? There's always going to be some sort of impact for the user. And that's where we focus. Now, we often spend a lot of time between those touch points because you have to do all this infrastructure development and all of the testing that goes into it before you can go back to them and say, well, here's what we did based on our conversation. What do you think? But you can at least get started early in that process by taking the prototypes to them, the wireframes and other things, before the product is really ready to demo them. In one case, we have a customer that liked what they saw at the beginning, but they didn't want to take it further into their organization. They didn't want to take it to their boss. They didn't want to take it to other departments until it was really ready, right? So we worked with them to refine the idea, and then they wanted to take it further. Okay, so there was one in the back somewhere. No? All right.
So do you deploy multiple services at once or one at a time, or you do a mix of that?
So for the way our services are aligned into the containers, there is a single service per container. The container will be restarted if it's been updated. So we have a process. So right now, I didn't really get into this, but right now the process of taking a ready product and pushing it into the staging or production environments is still manual. We are not yet ready in our evolution as a team and product to just let it go, right? If it passes the test, then give it to the users. So we still do those staged manual deployments. And, well, they're not manual deployments, they're manual pushes into a deployment. And what happens is that we have a script that goes through and says, well, if it needs to be updated, we use systemd. So if, as a part of that process, you have a new container, because it has a new build number, then restart yourself. If it's the same hash number from the build for this container, then don't restart it. Okay, in the front, there was somebody. Nope, all right, in the back.
So you mentioned that you are using the Dockerized environment for UI testing. So how do you perform integration and end-to-end testing where so many interfaces are in Dockerized environment?
Okay, let me go back to, let's see here. All right, so this is in the case where somebody wants to run a test in an integrated environment. So the question is, how do we test in the containers? We're using Docker Compose, which is creating a set of instantiated containers that mimic a deployment. So we're not actually, in production, we're using Kubernetes to manage pods, and we've got the feedback that happens there to make sure that the right number of pods are instantiated, and then if one of them fails, it gets restarted. All of that sort of operational stuff that happens in production, we don't really care about in test. So instead of standing up Kubernetes in our lab environment where all of the tests run, we use Docker Compose. And it has the similar connections between containers using the Docker networking that would happen if you were in Kubernetes in production. So they're still in that environment. Now, to test the interfaces between two containers, right now we don't have any tests that test like, this is just Kafka with Spark. There's no test that we need to do with Kafka and Spark. What we need to do is put data into the back end and see if it comes out the front end correctly. So we have a data generator that is also a clusterable thing. It can scale horizontally. You can spin up in effect, millions of users and have it be hammering your system with data that you control as a tester. And right now it's random, but we're about to roll this feature out internally where you can write a script that says, I want 1 million people to have 25% Wi-Fi on 10% of their devices. So we can then write a test that goes into the UI and says, okay, well, did that happen, right? Do we have an indication using the Spark analytics that's in our product that shows that 10% of the Wi-Fi devices have 25% Wi-Fi strength? So we test the component interactions through the end-to-end test. And this is the topology for that. When it's not containers, then it's just the mocked tests, and it's then just using it's only testing the UI.
Okay. So you tend to mention like UI testing a lot. UI tests are known to be like very, very slow tests and brutal tests. So like how much percent of your testing around the UI or on the backend?
So the automated testing using Protractor is all UI. That's we have other tests where the simulator is putting random data into a end-to-end test, and we make sure that things work, right? But as far as the pipeline is concerned of automated testing right now, we're using Protractor. Protractor is exclusively UI. And that is spread across the multiple Selenium nodes. And by standing up a lot of the nodes, on our laptop, on your laptop, you're able to do, what, 12 or something simultaneously? How many nodes do you have?
That depends on hardware.
Yeah.
On my laptop, maybe 6.
Oh, 6. Okay, so 6 on a laptop. But in our lab, we've got server-grade equipment, so you can run much more across multiple physical hardware. So you can just keep spinning up additional Selenium nodes, and it's all parallelizable, right? There's no for a given test, it may have some. Okay, so let me back up a little bit. We were using MSL. MSL has a problem in that it has a single server state for all of your tests. So if one of your tests changes a piece of data, all of the other tests see that changed data, which is not necessarily advantageous. So we changed to ngMock E2E because the server itself exists within the browser. The context for the data is specific to a test. So there's no interdependency problems between one test and the next. There's no test that we have where one test sets up the rest of the test, right? It would be a single test. It might be strung together internally as a series of steps, but as far as Selenium is concerned, it's one test. And you just throw hardware at it until it's fast. Yeah?
Why did you choose Protractor, and is there any disadvantages that you found with Protractor?
Well, our UI is based in Angular. And so the technologies that we're using are a lot of them come from working backwards from Angular. Like, how do you test Angular? So Protractor, and I think Karma is in that as well, and Jasmine. Yeah. So there's some of those technologies were chosen because they work well with Angular.
Any disadvantages, any problems with?
I don't know. Scott is the actual developer, so he's the expert here. Any disadvantages to Protractor? You can use this mic if you want. You'll get your public speaking in today, whether you like it or not.
So if your app is mixed with the JavaScript and Angular and not in a consistent way, then Protractor might be confused that it's Angular app. So then you have to do some configuration setting to say, okay, we're treating it as a Selenium app. So that way it's not
A Selenium app or a JavaScript?
or JavaScript app that only Selenium can. Well, it's essentially a Selenium wrapper, so you can do whatever Selenium can do. On top of that, because if you're testing Angular app, then it knows how to wait immediately. You know how to interact with the user input, and then move on to next user interaction without waiting. Mm-hmm. So that's the advantage of Angular, the Protractor. Mm-hmm. But yeah, the disadvantage is pretty much what Selenium has. So.
Okay. Thank you.
Okay, sure.
Yeah, we did use Selenium in the past with Java, but presently we're using it with JavaScript, right? Yeah. Okay, yeah.
You called out long-running tests separately from some of your other testing techniques.
Mm-hmm.
So what role do they play within your testing methodology?
So a long-running test, we have internally we have several layers of sort of like deployment onion skins. The first one that gets deployed to is an internal demo server, and it's always up, right? So anybody who on the team who wants to check to see if this code that we're planning on pushing to the next layer is working, they go to this internal demo server. And that one mimics a external deployment, right? We don't restart the kernel on that thing. We don't shut down the VM and recreate it. We don't start from a snapshot. So it's always there. And that in itself is a long-running test, because if you have an uptime on your host OS that's weeks or months, and then you have containers that get restarted several times a day, that's exactly what we do in production. So that's one version of it. Another version that we want to do, though we haven't had the time yet to get it done, is actually a long-running scale test, where you have a setup in our lab deployment, so we're not paying Amazon for this, that is just absolutely getting hammered for weeks and weeks and weeks. And that one wouldn't necessarily get updated, but it could be on the same release channel. We could control it so that it's updated less frequently or more frequently. And that would then tell us if there are any defects that exist that are only highlighted when it's a system under extreme load. And right now, this is a year-old product, so we don't have any extreme load deployments in production, but we could certainly test for that. Yeah.
You mentioned something about controlling Amazon costs. I'm curious what other techniques you use there.
So we do have, in our lab, we have a set of filers and blade servers and such that are using OpenStack, which is very similar to the Amazon infrastructure for us, as far as the way that you control networking and access and security and such. So that is our best way of controlling costs, is to just not put it in Amazon in the first place. If you go to the next stage, what we do for Amazon is we have 2 accounts that we manage there in a region, and one of them is for sandboxing. So in the sandboxing account, that's like the developer playground. You can do whatever you want there. If the costs start to get out of control, then we can like defer the testing to the next month, or we can shut down and do a smaller scale test or whatever. It can get pretty expensive, right? If you start up a bunch of like 2XLs and you leave them running for a month, it's going to be a pricey endeavor that you may not be expecting. If you have a budget, you don't have to worry about it. But then on the production side, then we just monitor with the standard Amazon controls for billing alerts and things like that to see if something is spiking. When we monitor, so one of the things we do with New Relic is it checks the output of our product. So it actually logs in and it checks one of the internal processes that's accumulating data from across all of the data that's coming in, and it checks to make sure that value is normal, right? So right now that normal just has, the normal is above 0. If that process dies internally, the number will be 0, so we get that alert. Well, we could also use that same technique to say, well, if this number is really big, then you're probably spiking on all of your CPU credits are probably tanking, and you're about to pay premium prices for these instances. It also depends on if you're using reserved instances, if you're prepaying the reserved. I mean, there's a whole bunch of Amazon accounting that you could do. But generally speaking, we rely on testing internally, testing in the sandbox, and building alerts. So, yeah. Anything else? Going once, going twice. All right. Thanks, guys. Check out the paper.